In this video, we are going over an idea that we actually talked about near the beginning of this unit. We're talking about how many solutions a linear system can have. So we talked about this graphically. We talked about coincident lines, parallel lines. So we are going to go over the same ideas, but approaching it from an algebraic point of view. Okay, so earlier in the unit, we found that a linear system can have infinite solutions. And like I said, we saw a graph of how a linear system can have infinite solutions if the lines were coincident lines. And then we saw no solutions. How is that possible? If the lines were parallel lines. And then we saw one solution. And that was pretty boring because we did so many different examples where the linear system had one solution. So one solution, slopes are different. Once you saw that the slopes of the lines are different, then there's going to be one solution for that linear system. So you know what? We are going to see how we can tell whether a system has no solutions or infinite solutions when we solve whether you use the method of substitution or elimination. Okay, so y equals 3x minus 4, y equals 3x plus 5. So hopefully you can tell yourself that this linear system should have no solution because the two lines have a slope of 3 and different y-intercepts. So we already know what to expect, but what's going to happen? All right, label the equations. So sub equation 1 into 2. So you get 3x minus 4 equals 3x plus 5. And then you get 0 equal, what? 0 equals 9? So we did expect something weird, right? We said that there should be no solution, and this is definitely weird. 0 equals 9. I don't know about you, but 0 equals 9, that is nonsensical. That doesn't make any sense. In fact, the x terms cancel each other out, and we're left with 0 equals 9. So what this is really saying, when you see something like 0 equals 9 or 0 equals 1, what you're really saying to yourself is that there is no value of x which will satisfy this equation. Okay, 3x minus 4 is never going to be equal to 3x plus 5. Okay, regardless of what you let x equal. And that makes sense because that's going to tell you that there is no solution to this system. Okay, 3x minus 4 is never equal to 3x plus 5, so there's no solution to this linear system as we expected. So since there is no solution to the equation of 3x minus 4 equals 3x plus 5, therefore there is no solution to the linear system. Okay, so I think you can already foresee what's going to happen here. All right, for the second example, we're going to do the same thing. We're going to solve by substitution. So let's see what's going to happen. 1 equals 3x minus all of 3x minus 1. 1 equals 1. You can say even 0 equals 0. Well, where do I go from here? Well, there's nowhere to go. Okay. So what this is saying, when you get 0 equals 0 or 1 equals 1, this is saying 1 equals 3x minus all of 3x minus 1. This is an identity. It's a very special equation. That means the left side is always equal to the right side, regardless of whatever you let x equal. Okay, so this is basically opposite what you said here. This is x is, no matter what you let x equal to, this equation will not be true. Whereas over here, regardless of what you let x equal, this equation will always be true. Okay, so there's a pretty big difference between the two, but at the same time, you can say it's a small difference. Anyways, let's summarize this. Since 1 equals 3x minus all of 3x minus 1 is an identity. Okay, this is a very important word down the road, but it's an identity, which means this equation is always true regardless of what x is equal to. Therefore, any point on this line, y equals 3x minus 1, is a solution to the linear system. So I let x equal a parameter t. You could have chosen any other letter. Yeah, so this is how you know whether your system has an infinite number of solutions. If you get this 0 equals 0 showing up, which means your original equation is an identity. It's always true. Okay, so we have something that's never true and something that's always true, because we didn't encounter many of these examples when we were solving our word problems or we're doing our practice with substitution and elimination. All right, we have a linear system here. We are told that there are infinite solutions for this linear system, which means that these two equations are really the same. Determine the value of a plus b. Okay, so what we're going to do is we're going to take the first equation and multiply it by 3. And we're going to take the second equation and multiply it by 5. Now, why did I choose those numbers? Because I want to change the constant term to both of the equations to be equal. And I'll explain why later, but let's do it and then we'll see. So this becomes 3ax, this becomes 9y, and this is the 15 I really wanted to see. And then this is going to become 10x, and this is going to become 5by, and 5 times 15, of course we want to see that 15. Let's quickly check. 2 times 5 is 10. Okay, good. So why did I want to see a 15 for both of my equations? Because now what I can do is equate the coefficients, right? Because when the constant terms were not the same, I cannot equate the coefficients. Okay, but now that they both have the same constant term of 15, everything else must be the same, because we said that they're infinite solutions, which means the equations are identical. Okay, so now the coefficients must be the same, whereas before they're allowed to be different. Okay, b and 3 are not the same because the constant terms are not the same. But now that I've made the constant terms be the same, the other coefficients must also be exactly the same. And once I set my coefficients to be equal, I can solve for a and I can solve for b, and I can tell what a plus b is. So therefore, guess what? 3a equals 10. And you can also say 9 is equal to 5b. Okay, let's solve for a and b. A plus b, let me just quickly check. (77/15). Okay, so we went over the same idea, but this time algebraically. So don't be confused when you see an equation where there's no solution or there are infinite solutions. That just tells you either you have infinite solutions or no solutions to the linear system. that's it basically. So we're done the unit. The next few videos will basically go over the big ideas.